Yeah. Hi, everyone. My name is Neha.
This is Nivedita.
This is Rutuja.
Hi, I'm Soumya.
So we would like to introduce Mr. Sparsh Gupta, Staff Data Scientist at Intuit AI. Hi, Sparsh. Thank you for joining us.
Hello, everyone. Nice to meet you all.
How are you, Sparsh? How's the weather in New Jersey?
Doing good. The weather is not as well. It's not as nice as California. It's been raining for a few days now. Doing okay, I guess. Missing California a lot.
So Sparsh, would you like to tell us something about your journey?
Sure. Yeah. I mean, well, do you mean journey specifically in terms of ML in industry, or just my ML background?
Yeah, you're like something related to ML in the industry, or how you got into it, or your educational journey.
Okay, sure. Yeah, sounds good. So basically, I did my master's in from UCSD in computer science with a focus on machine learning. And since my undergrad, I've been doing a couple of projects in machine learning. I had taken a few courses, and even in UCSD, most of the courses that I chose, they were machine learning related itself, both in computer vision, language processing, classical machine learning, deep learning. And then I was fortunate enough to get an internship with Intuit AI, and that is basically how I got into machine learning as a profession, if you will. And then within Intuit, over the last almost 5 years that I've been here, I've primarily worked on NLP projects. That's my main field of interest. My internship was in NLP, and yeah, so I guess that's my journey so far. So just doing a lot of projects in college, taking a bunch of courses, and then because I was interested in NLP, just doing an outreach on LinkedIn and on job portals. And again, just internship was the door for me into the ML industry. Is that does it sound good?
Yeah.
Yes.
Yeah,
So
thank you so much, Sparsh.
I had a question. What are some of the challenges you face while working with the machine learning models in your day-to-day work?
Yeah, sure. So I think the biggest challenge is the data itself. So I mean, in college projects, or the data sets that you typically find on Kaggle or other websites, well, Kaggle also has a lot of industry data sets from industry, but more often than not, these data sets are cleaned, processed. You know that there'll be labels, few missing values here and there is fine. With industry, I think the biggest problem is the data itself, because first of all, figuring out how the data is collected, what are the processes that generate the data, or let's say I have to develop a model to serve a particular part of the product. Sure, but what kind of data do I need? Is that readily available to me? So I think, and if it's a lot of the times there's discrepancy in the data itself. For example, one user ID mapping to two different other IDs of some other things. Now, how the hell do I figure out which is the right one? So a lot of the time, a lot of the ML lifecycle time, if you will, of mine goes in wrangling these data effects. And I felt that more often than not, if you arrive at a state where you can clearly define, hey, this is going to be my training set, test set, these are going to be the metrics that I'm going to evaluate on. I think that point onwards is what it's like in the college, where you experiment with a bunch of different models and measure the outcomes and report them. But I guess assembling that data, identifying and assembling the data, it's pretty challenging.
Yes. Okay. Yeah, that answers my question.
Great.
Thank you.
Yeah, so I would like to ask the next question. So going with the algorithms, so which one do you think that you use the most in your daily work? So we are looking at, I mean, we are starting from the basics of ML, at least with this course. So with respect to the basics, at least, so which all are the models which you think are the ones which you even use till date in your industry?
Sounds good. So basically, talking, language and vision aside, because these are specific domains now, but when it comes to your classical ML models, if it's a classification problem, to be honest, I just directly jump to XGBoost, simply because in all these years, what I have seen is across the board, across several data sets that I've tried, XGBoost generally tends to provide better performance than your random forest, definitely better than decision trees, but better than random forests, or even your logistic regression. In some cases, especially for tabular data, I've even tried neural nets, but XGBoost actually outperforms neural nets in a lot of cases. So that's the go-to model that I have. But that said, it is important to set a baseline as well. So as a baseline, then I just go ahead with the random forest classifier, just to get a sense of how difficult the problem is. Like, if XGBoost is outperforming random forest by a lot, then I know that okay, it's a tractable problem and we are making significant progress. If both of them perform equally well and the numbers don't look that well, then the problem is difficult. So you get an idea if you set a baseline, so to speak. But then yeah, XGBoost is my go-to model when it comes to classification. For regression, I think most of the problems that I worked on, they're classification based. Yeah, regression, you could use a random forest regressor in sklearn, and I guess that works pretty well.
Thank you. I think that answers.
Yeah. So with the recent advancements in machine learning these days, like as AI has come into picture and AI is the new hype, how do you think it has impacted the real world applications?
Uh, by a lot, I feel. I mean, the most recent example I'll give is of ChatGPT. Since it came out, I think pretty much all the websites, in my mind, the analogy is all the company Silicon Valley based companies, but essentially you'll see that most of them have made an advance on this, adapting it into their user experience. So Expedia, for example, they have a plugin for ChatGPT. Like if you look at the ChatGPT code, you see the Expedia plugin, but if you go to Expedia, you actually see that it now enables a nice chatbot for you, where you can actually do actions like make reservations and cancel stuff. I have a Chase credit card, and even Chase have adopted this. So this is just one example of a thing coming out and how quickly it's adopted. Even at Intuit, as soon as a lot of Gen AI based models started coming out. I don't know if you've heard about Intuit Assist, but that is there's an entirely kind of logical operating system that Intuit has designed that leverages a suite of LLMs to actually orchestrate calls to other LLM models, which then serve Intuit products. So it's just as I said, there's just one example how this has penetrated the industry. If you talk about, take a few steps back, even classical machine learning models, I think they are widespread in industry. Any websites that you go through that recommend you anything, even the ad recommenders, websites that track your clickstream activity and so on. So all of these use machine learning solutions nowadays. So yeah.
Yeah, that answers my question. Thank you.
So Sparsh, like we have been taught math a lot in the part of ML course, right? So what do you think? How relevant is the academic math taught as part of ML course in colleges with respect to the usage in the industry?
Uh, See, there are two aspects to this. So in your day-to-day work, when you are, thinking about, let's say, hey, there's this problem, I have to develop a model for that. Maybe not as much, because it's a given that let's say you're hired as a data scientist somewhere. Of course, it is an assumption, and of course, more often than not, it's the case that you are familiar with the different machine learning models, their pros and cons, and so on. So in day-to-day life, it's Python and a lot of data exploration, experimentation, and all of that. So math itself does not come in very handy, as in you don't directly use it. Just that, you have an understanding of the models that makes sense. That mathematical understanding makes sense. Now, when you talk about new stuff that's coming out, so again, I'll use LLMs as an example because for the last couple of years I've been working extensively in NLP. But with the new papers that are coming out now, if you want to understand them, a lot of these papers, they actually use math, and I feel subjects like linear algebra, uh, your matrices. Well, calculus was important in the courses where backpropagation was being taught, but again, to actually understand how backpropagation works, and then later on understand papers on adversarial networks. And again, if you want to understand upcoming papers, that's where this math definitely comes in handy, because all the paper will do is just mention an equation. And for me, it actually took some time to get a hang of, okay, I can read it and I can kind of visualize. So what I used to do is kind of draw a matrix. Paper says it's L cross D. I actually drew a matrix and saw how things must be going on. So it actually helps a lot, all of these subjects, when you're reading papers. So again, there were two, I guess, aspects to this. I hope that
Yeah.
clarifies how much math is used.
Yes. Yes. Thank you.
Yeah, so I have one more question. So currently we are learning SVM in our course. So what is the significance now? I mean, what is the significance of SVM right now?
Significance of SVM right now. So again, to be honest, SVM, and this is purely from a practical consideration, I believe, at least in the last 5 years, I feel I've only used SVM as, one of the models that I'm testing when I'm trying out a classification problem. And again, XGBoost has been performing better than SVM, for at least for the data sets that I've worked on so far.
Okay.
So uh, it's a really good classifier. I mean, theoretically, it's very sound. It's just that, again, practically, I guess, I tend to use XGBoost, or not even XGBoost, but I guess, yeah, actually, I tend to use XGBoost more often than not, being honest. So I don't know if that answers your question. With
Okay, so I mean, I would say that it depends on the problem.
It certainly depends on the problem, but as I said, for me, it's a pretty solid model, XGBoost, so it works for most of the cases. But yeah, it's if for your problem, it's definitely worth trying it out. If SVM works better, that's really great. Yeah, you can try out different kernels, and some problems might be more suitable for a particular kernel and might just work out.
Sure. Thank you. Thank you so much.
Yeah, I think I'll go next. So now that a lot of advancements are being made in this current industry, so how do you keep yourself updated? So there are plenty of materials available east, west, and everywhere. And how do you keep yourself on point and updated? And how do you keep revising your old stuffs, and how do you do it?
I'll answer the later part first. Do I keep revising the old stuff? No. I mean, yeah, I. So the thing is, I mean, you revise concepts as and when you need them. At least that's how I've been doing it. So, once you've gone through the courses, once you've developed an understanding, I guess in your day-to-day applications, it's all right, if you don't exactly remember what it is. For example, if we talk about SVMs right now, I don't really remember what Gaussian kernel looks like, but the thing is, when I'm solving something and I need it, I can always Google it. And if I have a sound understanding, the moment I guess I need it, it'll be more like a refresher for me. So it's not like I'm actively going back to refer it, but as and when I need it, and if I feel that, hey, this is something I'm not able to recollect, uh yeah, I'm able to, I just Google it up. Now, how do you keep up to date with the current advances? So I guess what I have done is, on social media, which is basically Twitter and Facebook. I've joined a lot of groups and enabled only those notifications from those groups, where a lot of people post papers about deep learning. And if you want, I can share you links to some of these Facebook groups. But yeah, so yeah, to be actually honest, a lot of it is that. And secondly, at Intuit, I mean, we use Slack internally for all our communication. So we have a lot of machine learning based channels as well. Like there's a dedicated one for Gen AI, there's one for computer vision, and so on. So people keep posting relevant papers there. So I guess, and one more place is Reddit. But I guess for me, Facebook and Slack, like Intuit Slack channels, they do the trick. But I guess the idea is to be online and I guess be on the lookout for whatever papers are coming out. You don't need to read every one of them. I think for most of them, the abstract is enough to tell whether this is something that you really, because again, there are so many papers coming out, it is impossible to read and understand everything in detail. So you just try and, filter out, hey, is this relevant to, let's say, what I'm doing, or is this relevant to what I'm interested in? Just pick and choose the papers of interest, read a few once every few months, and I guess that's how I try to keep myself updated.
That's perfect. That helps. Thanks.
Yeah, I'll go next. So, as we know, like the most used programming languages for machine learning are R programming and Python. So, which one do you use in your daily work? Which one would you prefer, and why? And which one has the higher demand in the market?
So I would say it's Python through and through. Not saying that R is not a good language, but I feel that the versatility of Python makes it very useful for industrial applications. Python has it's open source, so there are a lot of developers coming out with a lot of new things. For example, the recent project I'm working on, we actually are paused on deployment because the package that they're using, they're coming out with a new major version release every couple of weeks. So we need like a stable version before we can go into production. So basically with Python, I feel that's the advantage. With R, they had an extensive use, toolkit for statistical analysis and for statistical modeling. But now all of that is available in Python as well, with the same level of precision and multiple packages trying to do the same job essentially. So because of all these reasons, I feel that yeah, Python is my preferred language, and industry also prefers Python because of all of these reasons. Easier for development and easier for productionization, because you have again a lot of toolkits available to interface your Python inference code with the downstream servers working on Java or something. So all of these just make Python a lot better than R.
Just a continuation to this question. Yeah, I think we can wrap up after this. So is Python the only language that you rely on, or are there other languages which you use as well?
I use SQL as well. Well, I don't think
other than SQL.
Yeah, okay, other than SQL.
That's
No,
like
no.
non-negotiator. Yeah, we need SQL.
Exactly. No,
Yeah.
then yeah, other than Python, I don't think I've been using anything else, and I don't think I used any other language even during my coursework. I mean, back then, Torch, I mean, well, PyTorch had just come out, but Torch existed separately, and Golang exists, but no, we never had to use any of it. And again, with I've been working primarily in NLP, and with NLP, all the latest work that comes out from academia or from industry, both open source and otherwise, it's all based in Python. So at least for me and the teams on the relevant projects, Python makes the most sense to use. It makes the most sense to use Python.
Perfect. Yeah. Even for LLMs, Python is the language, right?
Yeah, absolutely.
One last question. So what are some things we should keep in mind when joining the ML industry?
Keep in mind that's actually quite broad. I mean, can you tell me like if there's any specifics or any kind of
Jobs related to ML? So what are the things in mind? What should we keep in mind when joining something related to ML jobs industry?
When joining, all right, I guess I can give again, I guess be as specific as I can. But one thing that I have learned over time is that which is the biggest challenge that I was referring to. Again, in college projects, the data was very clean, very nice, very easy to work with, and I didn't have to think a lot about. So my approach used to be, all right, here's data, pd.read CSV, and that was just data handling part. What I did. So for me, I guess the biggest learning was, and it took me some time to get into that practice, to be very honest. But I guess one thing to keep in mind is just do your data analysis properly. Try and see what the class distribution looks like. If there are too many null values in a particular field, or if a field is not being populated because of some engineering artifacts, just try to understand your data as much as you can. And secondly, again, what I said, try to define the business problem in terms of data science problem as well as you can, and that means defining your metrics well, like how you are going to evaluate, how you are going to test, because ultimately that is going to define, or that is going to decide the quality of the model that you end up submitting for production. So I guess yeah, those are the two things I would say when you are joining the industry. Just keep those in mind. But I guess every day is a new lesson.
Just a continuation again. So do you still get your hands dirty, like with the data part at least, or do you just now that you are in a much higher position in your industry, so do you still work on cleaning and processing the data, or do you still get involved in that, or do you just supervise at a managerial level?
No, so well, the way Intuit is structured is the managerial track and the here we call them ICs, individual contributors. So those tracks are completely different. So I'm an individual contributor, which means any project I have to work from scratch on it. If I'm lucky enough, the data is again very nicely available in a table. I just have to join a few, prepare a data frame, and that's it. But there have been projects where I've spent 2 to 3 months just trying to figure out the SQL pipeline. And that was a very bad project. The underlying pipelines were buggy as well. So there was a lot of getting hands dirty. And even at, in the individual contributor track at Intuit, at least I can say that your senior staff data scientists or principal data scientists, I think all of them, if you are working on a project and the division of responsibilities is such, then you of course you work on the data, and it's actually nice to be able to look at the data before getting to modeling, because at least that way you are able to visualize once you see the model errors, like what could be going on with the model. So yeah, I do get a chance to get my hands dirty.
That's perfect. So you would still agree that at least 60 to 70% of any project's time would go into cleaning the data and rearranging it, right?
That is correct. Yes. Yes. In fact, the one that I'm working on, we've halted a bunch of things, and I have to figure out the data part by end of May. So, data itself takes a lot of time to figure things out. Yeah, it takes up 60 to 70%. Yeah, for sure.
Perfect. Yeah.
Since you talked about modeling and the errors while modeling, so I wanted to ask what are the approaches that you follow to tune hyperparameters for any model, and how do you go on selecting the optimal hyperparameter while working with the real world data?
So basically, to be very honest, for again now I'm not doing any hyperparameter tuning for deep learning models, because training the model is pretty expensive now. So you only have few chances of training the model, so you just decide to go ahead with and because it's more expensive, so there are a lot of blog articles. So I subscribe to Medium as well, actually. So one of the social media channels to follow would be Medium. I get regular mails there, and if papers of interest pop up. But yeah, I'm sorry, I lost track of the question.
Yeah, how do you select optimal hyperparameters within?
Right, yeah. So on the Medium blogs and all, you can find again, if a lot of people who post kind of their experiences, like, hey, these are the hyperparameters that work best. Well, actually, while all of this was developing, Andre, a few influencers, if you will, in the industry, well, they've been tweeting about, we tried this out and this hyperparameter worked best, and so we just take that and we run forward with it, again, because so much to explore. You can't get bogged down by each and every hyperparameter. So that's deep learning. When it comes to classical machine learning, I guess hyperparameter tuning, there are packages, Python packages that you can use to do hyperparameter tuning. One approach is just to, try a few values out and record the results on your validation set, and whatever performs best, that's the one you go with. So a mixture of things, but certainly for deep learning, it's not viable anymore to try out hyperparameters. Uh, so yeah.
So since you mentioned like few packages,
Mhm.
do you have anything on top of your mind which you can tell us?
Yeah, I was trying to think about the name, but I forgot the name. I would have mentioned it if I remember. But I'll look it up. It's a popular one. If you look at any, again, Medium blog, you'll find that's the, yeah. I'll send that to you. No worries. Yeah, I'll send it over.
Thank you.
Yeah, so now that ChatGPT has taken over everything by a storm, so one question which runs into all of our minds are, do we have a job next? Will we still have a job? If so, like till what level will the LLMs will take over, and what will be the job left for us? So how would you see this?
See, I think the at least, and that's actually a really good question. The reason I feel is because I'm also learning this as I'm working with LLMs for the last 1.5 years, and what I've realized is that while they do have the potential, because I mean, I've experimented with what to train. Well, so there's a product called TurboTax. We have our Intuit specific language that calculates your taxes for you, and it was like in a 10-year-old legacy language. So one thing I tried out was to convert all of that into Python, the entire logic of that. And the GPT-4, it's actually a very impressive model, and it performs really well. Even the delta between GPT 3.5 and GPT-4 is huge.
Yes.
It's really, really well. So in terms of potential, well, yes, it has the ability, and if you follow the Open LLM leaderboard, people are coming up with new and new combinations of LLMs that perform better and better on math tasks, on programming tasks, which is primarily the space that we deal in. So in terms of potential, sure, in future there is the potential, but there is one thing to have this capability, and there's whole another thing on how to efficiently productionize this so that you are making money out of it, right? If I'm running a business, it should be financially viable for me to have this machine run the code that let's say n engineers would write, or run the code, validate the code, do system design, do everything in such a way that is sustainable, that is robust, and that survives long-term effects throughout, I guess, tech evolution. Right. Ensuring all of that takes up a lot of time, energy, investment, and it's very hard to get all of this right to an extent where you feel comfortable that, hey, we are able to send this to production. And again, I'm able to realize all of this as having a first-hand experience on trying to put something to production which is based on LLMs, and it has been very challenging path for me. So it is because of that reason I feel that while they have the capability, efficiently productionizing them is not uh, gonna be anytime soon, at least with the devices we have right now. A lot of research is going on in making LLMs faster and lighter. But even with that, right now, nothing commercially exists which can make them fast enough to be of such widespread use that you start replacing engineers with that. That's
We still have 10 to 20 years of job.
yeah, absolutely, absolutely. I was just discussing this with my wife yesterday, like, but primarily about NVIDIA stocks, like, how GPUs are here to stay for some time. And, unless someone makes a breakthrough in quantum computing, which just makes running a lot of these deep learning computations easier on a quantum computing machine, I don't think there's a lot that we can do from a hardware perspective to, significantly speed things up. So I don't think anytime soon it's going to be very commercially viable to start replacing jobs. Yeah.
Perfect. Thank you.
Sounds good. Were there any more questions? Anything else I can help with?
I think
Yeah,
that's
I'm good from my side.
thanks a lot, Sparsh. Like
Thank you. Thank you so much, Sparsh.
that was
Awesome. It was really nice talking to you guys.
Likewise.
Do you have any suggestions for somebody who will be graduating fresh out of the school and like entering the ML market? Do you suggest any skills that we should pursue, and I mean that would help in long run?
Any skills that would help in long run? Well, I would say if you know Python and Python libraries and or of that machine learning knowledge. Yeah, I'm trying to think in terms of industry, if there's anything. There was a phase where, having the knowledge of Hadoop, it used to be pretty actually it still is. I should not say that. It's just that I don't work in that space anymore. Even with large data set sizes, we just use SQL. So I'm not using it anymore. But yeah, I guess that would be something that you can definitely hone your skills there. Because a lot of companies still, it's a very efficient way to handle big data. So a lot of companies would still be using it. So that is one thing I can certainly think of. Other than that, no, just yeah, I guess just keep your foundational knowledge strong. Oh, one thing that as an interviewer, what we look for when someone applies is that how well because ML is such a wide field, it is impossible to expect of someone to know everything or just everything that the interviewer would be knowing. But the expectation is that whatever you're writing on your resume, you know that inside out. By that what I mean is I can ask you, why did you choose this model? What are the pros and cons of this? What if I do it this other way? What would happen the other way? Or why did you choose this metric? What are the edge cases there? So you must know all of that inside out for sure. But yeah, I guess and Hadoop, big data handling. Those are the two things that come to my mind.
I have one question. So
Mhm.
right now, you said Hadoop. So
Mhm.
Spark is also in the market. So
Right.
I mean, if we want to go should we go with Hadoop or
No,
Spark?
I mean, yeah, I guess any big data handling framework. So Spark, Hadoop, anything works. Well, yeah, actually, more than Hadoop, I've worked with PySpark. I'm really sorry. By Hadoop, what I meant is just big data handling. It could be any tool. So yeah, you can use PySpark as well. It's a perfectly fine tool. In fact, yeah, PySpark would be well, since I mentioned, with a heavy focus on Python in the industry. I guess PySpark would be a nice tool. Again, I guess to be honest, it really depends on what the company that you end up joining is using. And I guess the skills are transferable. So if you learn one, it's fairly easy enough to adapt to other tools, not just these two, but any of the tools. I guess well, I'm forgetting, on Kaggle, there were a lot of new data frame loading tools that also came out that claimed that, we load the data frame much faster than pandas. So things like merging of data frames and same thing, but merging of data frames, processing stuff, we do that much faster than pandas, and especially for big data. So there are a lot of toolkits out there, but even if you get hands-on practice on one, I guess it's fairly easy to adapt to any of the others.
Got it.
Yeah, so I think that's it from our end. Sparsh, thanks a lot. That was really insightful. Like, this gave us a lot of perspective into the industry. And since we are new to this field, your answers really helped a lot.
Um,
They answered many of our questions. So yeah.
Sounds good. Great, I could help. And again, if there's anything else, please reach out. I'll certainly send the name of that package that I mentioned for hyperparameter tuning. But yeah, again, if there's anything else, please feel free to reach out.
Sure. Thank
Sure.
you so much for your time.
Thank you so
Thanks a
much,
lot.
Gupta.
Thank you so much.
Thank you. Bye bye. Have a
Have a
nice
good
one.
day.
You too.
Bye.
Bye.